A dilation. What does a dilation do?
Makes things smaller.
Makes a shape either bigger or smaller. Good. Now, if you remember from the very first day of transformations, a dilation is the only type of transformation that is not what?
Rigid.
Good, not rigid. It is not a rigid transformation. The shape is changing. It's being made smaller or bigger. Enlargement. What's another word for enlargement?
Expand.
Bigger. Expand. You have same thing. And shrink means smaller. Good. Now, who knows what a scale factor is?
How much you're enlarging.
Right. And how do you apply a scale factor to something? Multiply. Good. Number of times. The times means multiply. So a scale factor is the number of times, the number of multiplications, bigger or smaller a shape gets. Now if I use S for scale factor, if I'm trying to make something bigger, the scale factor is going to be what to 1? Bigger than 1. And the scale factor for smaller will be less than 1. Good. Okay. So now we're going to do the easiest type of dilation. Just dilate about the origin. We're being asked to dilate this shape by a factor of 3. Oh, that's too big. So the first thing we're going to do is plot these points. We have 2, 2 is A. Then we have 3, 0 is B. And we have -1, -1 is C. And we're being asked to dilate this by a factor of 3. How would we go about doing a dilation here, Fargo? Beautiful. We're multiplying everything by a factor of 3. So, what's 2 times 2, Bargo, you said? I mean, sorry, 2 times 3? 6. Good. And 2 times 3 again? Anybody? Good. And 3 times 3 is? And 0 times 3 is? And -1 times 3 is? And -1 times 3. Beautiful. And then we just plot those points to finish up. So we have 6, 6 is our A prime. And 9, 0 is, B prime. And -3, -3 is our C prime. Oops. Oh my gosh. Any questions on that dilation? Pretty straightforward. Now, what would make this dilation harder? That's what I'm looking for. Do you think when I ask what makes this harder, do you think that I would say using a fraction would make this harder?
No.
Do you think I would say using a fraction would make this harder? No, fractions are not harder. It's just a different number. Fractions should not be considered tough. I swear by the end of this year, I'm going to make it so that you appreciate fractions just as much as I do. What would make this harder, Morning? You said it.
If it's not about the origin.
Yes. If a dilation is not about the origin, we have to do different steps. So over here it says dilate the figure below by a factor of 2 about the point D. That's the trick here, about the point D. Now I know on yours it didn't print very well. You should put a an actual point at 1, 2, 3, 4, 5, 6, -2. And also there's a misprint. The C should not be at 5, 2. It should be at 1, 1.
Bless you.
Bless you. Okay, so the first thing we're going to do is plot these points. So we're going to have 1, 4 is A, 3, 3 is B, and 1, 1 is C. Now, we're going to do this step by step. Our first step is to create a new set of X and Y axes with the new point you are dilating about as your new origin. It's not very bright, is it? It's a little better. Okay, so we are now creating a new set of X and Y axes with D as our new origin. So if you have a highlighter, now is a great time to use it.
What if we don't?
Then borrow from somebody else. So I'm going to draw a set of X and Y axes with D as the origin.
I must have lost it. That's fine. I think I might have one. Oh, do you have to highlight?
I would highlight. I just can't because I'm writing on a black surface, so it's hard for me to highlight, so I'm just using a marker. But you guys should highlight a new y-axis and a new x-axis centered at point D.
Oh, all the way around.
That's our first step. Step number 2. Step 2 says, write down the coordinates of your new points of your points based on the new X and Y axes. So, what this means is we're treating D like it's the origin, right? So, if D is our origin, what are the coordinates of our A? From D, I went over on the x-axis how much? 1, 2, 3, 4, 5, and I went up 6. So the coordinates of A with D as the origin are negative 5, 6. I'll do it again. For B, treating D like our origin, B on the x-axis is over 3, so negative 3, and up 1, 2, 3, 4, 5. So B is located at negative 3, 5. And C, C is at negative 5, 3. Good. Okay, so that was step number 2. Step number 3 says, go up. Oh, just there. Step number 3 states multiply the new points by the scale factor and plot those multiplied points. So, what is our scale factor? 2. Up here we were asked to dilate by a factor of 2. So, I'm going to take these points and I'm going to multiply everything by 2. So, what is negative 5 times 2? Good. Negative 10. And 6 times 2? Yep. 12. And B prime, we're multiplying both the x and the y by 2, so negative 3 times 2 is great. And 5 times 2? And negative 5 times 2 for the C is negative 10. And 3 times 2. Good. So these are the coordinates of our new points. So now it says plot these multiplied points, and we're plotting them on the new x and y with D still as our origin. So A from D is over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 12. That's our A prime. And B is over 6 and up 10. And C prime is over 10 and up 6. Any questions so far? Okay, let me show you something a little interesting. If we hadn't dilated about point D, instead we had dilated about the origin like normal, our triangle would be, ooh, that's huge. Our triangle, the C would be here, the A would be here, and the B would be here. Oops, B. So what do you think happens? Yes.
It's like, kind of like a translation, kind of from like the origin to D is the same thing from the first shape to, or the new shape to like what it would be around. Do you kind of go?
Yes, I think I do. So if we're looking here, dilation, to look at the new dilated shape, is kind of like we had a projector, right? We had a projector or a flashlight centered at the origin. So if we had a flashlight centered at the origin and we're shining it at the original shape, the shadow it creates is our dilated big shape. But instead of having the flashlight at the origin, we instead had the flashlight at D, projecting the other way. Do you see it? Also interesting to note is that the distance from the point, so look at the distance from C to D. You see that distance? What is it compared to the distance between C and C prime? Oh, they are the same. They will always be the same. The distance from your point of dilation to the new dilated point will always be the same. It's just interesting, I think. Okay, so on to finishing this dilation, because we haven't finished yet. We have one more step. One more step. See the step 4? Our last step is to find the coordinates of the new points based on the old x and y axes. So, if I'm looking at our dilated shape, and I now have the origin being back where it's supposed to be, right in the center, 0, 0. Where is A prime now located? I went over 4 and up 10. So my A prime is actually located at -4, 10. Where is B prime? 0 and up 8. And C prime? Over 4, so -4 and then up 4. Now, the only reason that this took so long was because we wrote out the steps. Really, you could probably simplify this down a little bit. Like, do you really need to draw the X and Y? Well, no, because you can look, okay, so C is from D, you go over 5 and up 3. I need to multiply those both by 2, so I go over 10 up 6. And I put it there, and then I just find where the new coordinates are. So you only need to use these steps to the letter if you don't really understand what's happening here. If you understand what's happening and you're able to skip some steps, go ahead. Okay. So, any more questions? All right.